Welcome back. Again, my name is Chris Dunn, and I am the Director of the Hydrologic Engineering Center. This is the third part of a four-part series introducing ER, or Engineer Regulation 1105-2-101, and providing background on policy and regulations for risk assessments. Specifically, in this presentation, we're going to introduce you to the NED Plan, or the National Economic Development Plan, and its reporting requirements. So the objectives. In previous presentations, we provided a basic introduction to ER 1105-2-101. We explained the risk framework, and we defined key risk assessment terms and sources of uncertainties. In this presentation, we're going to define the NED Plan, the National Economic Development Plan, and help you understand the economic and performance reporting requirements. Communication and other considerations identifying impediments to the risk assessment will be captured in the next presentation. So what do you report from a risk assessment? In other words, what alternative or plan do we have to identify and possibly recommend? From an economic perspective, it is the NED, or National Economic Development Plan, that reasonably maximizes your expected net benefits. And the net benefits will be calculated explicitly, including uncertainties in the key variables specified in the risk register. Also, it's important to point out that increments in project scale beyond the NED plan, something other than the NED plan, as well as other plans preferred by the local sponsor, is permissible to improve project performance and to manage residual risks to people and property. Existing policy governing project increments beyond the NED plan must be followed if you are to try to recommend an alternative other than the NED plan. So once you have identified your recommended plan, once you've identified the NED plan, then you need to develop these reporting requirements. So these values start with the annual exceedance probability with the associated description of its uncertainty. And as we pointed out in the previous presentation, the annual exceedance probability is the likelihood that a stage will be exceeded or a structure or project will get wet in any given year when considering all possible events and project performance. So it's the likelihood that you're going to get wet in any given year based upon all the possible events that could happen, flood events, hazards, as well as your project performance. LTEP, or long-term exceedance probability, must be developed over 10 years, 30 years, and 50 years. And all this is the likelihood of getting wet in a 10-year time period once or more than once, in a 30-year time period, or in a 50-year time period. So LETP is the long-term exceedance probability, or the probability of getting wet, 10-year time period, 30-year time period, and 50-year time period. Assurance, also known as conditional non-exceedance probability, is the probability that your project will actually protect you from these various events, probabilistic events that are specified here. That's the 5, 10, 50, 100, 250, and 500-year events. So what's the probability that your project will actually protect you from those events? That's assurance, or conditional non-exceedance probability. In addition to looking at those probabilistic events, you also have to look at assurance for specified historic floods. So floods in the past, what's the probability that your project, the NED plan, for example, will actually protect you from these past historic events? So those are your performance measures. Now your economic measures are your economic average annual and single event damage values, potential loss of life, and environmental considerations and impacts as required by 1105-2-100. So qualitative and quantitative statements of residual, transformed, and/or transfer risk must also be provided, and you would do that in the narrative, which we will show in just a few slides. So in Appendix A of ER 1105-2-101, there are many examples of reports that can be generated. Remember, these are examples. You don't have to use these reports exactly, but they're good rules to follow. In this particular table, you see 7 alternatives. You see the mean annual exceedance probability and the LTEP, or long-term exceedance probability, for each of the 7 alternatives. So let's just take without, for example. So your mean annual exceedance probability is 25%. That means you have a 25% chance in any given year of getting wet in that floodplain. In a 10-year time period, you have a 94% chance of getting wet in that floodplain in a 10-year time period. You have a 100% chance of getting wet at once or more than once in 30 years, and obviously you then have a 100% chance of getting wet once or more than once in 50 years. Now, if we take, for example, the 25-foot high levee, in this example, you have about a 1% chance of getting wet or the levee being overtopped if you put in a 25-foot levee. In 10 years, you have a 10% chance of getting wet. In 30 years, you have a 26% chance of getting wet or having that levee be exceeded. And in a 50-year time period, you have a 39% chance of that levee being exceeded. That's one way of looking at your performance indices. Another way is just looking at the odds. Instead of the probabilities, we're looking at the odds. So this table is exactly the same as the previous table, but in this table, we're looking at the odds. So back to the without project alternative. In 10-year time period, your chance of getting wet is 1 in 1.1. Your chance in getting wet in 30 years is 1 in 1, and your chance of getting wet in 50 years is 1 in 1. If you go back to the 25-foot high levee, your chance of getting wet in 10 years is 1 in 10.5. Your chance in getting wet in 30 years is 1.38, and your chance of getting wet in 50 years, once or more than once, is 1 in 2.5. So they say the same things, just different ways of saying the same thing. Now, the other thing that we have to do is we also have to provide the uncertainty about our annual exceedance probabilities. So in this figure, we're showing you the uncertainties about the 25-foot high levee and the uncertainties about a non-structural measure like relocation. So let's just look at the 25-foot high levee. So you have a 1% chance of getting wet in any given year if you build the 25-foot high levee. However, the uncertainty about your estimate of that shows that you have a 75% chance that you'll be protected from something less than the 200-year event. You have a 50% chance that you're going to be protected from the 1% chance event, and you have a 25% chance that you will only be protected against the 52-year event. So that kind of gives you a bracket that says somewhere between 75% and 25%, you're protected from somewhere between the 50 and the 200-year event. But your mean value is that you're protected from the 1% chance event or the 100-year event. So it gives you some flavor for how well you know how well you're protected. In the relocation example, okay, you're somewhere being protected around the 50-year event on a mean annual exceedance probability. But you have a 75% chance that you will be protected against something less than about a 70-year event. You'll have a 50% chance that you'll be protected against something around a 50-year event. And you have a 25% chance that you'll only be protected from a 33-year event. So it kind of, again, it brackets what you could expect your project to be able to do for you. Other reporting requirements, now we've moved from performance requirements to economic requirements. And here we're looking at the same alternatives, only the without alternative is in the first column under your expected annual damages. So without alternative, you can see is the same every time, $575,000 worth of damage. And that applies because that's your without project alternative. Now we're going to compare that to our with project alternative. So if we look at the 20-foot high levee, you can see that the with alternative expected annual damages is only 220. So moving over to the right, that means your mean damages reduced is 355. 575 minus 220 is 355. So you're going to have a reduction of damages of 355,000 if you put in the 20-foot high levee. So if you look at the damages reduced, which of the alternatives gives you the highest damages reduced? Clearly it's the 30-foot high levee. Not unexpectedly, it's the 30-foot high levee. But in addition to that, you also have to have the uncertainties about the expected annual damages reduced. And that's what you see in the last three columns, is a probability distribution of your expected annual damages reduced. And again, it gives you a flavor for how well each of the alternatives are going to protect you. So beyond just the mean value, you actually get these quantiles that can help you determine whether you have a lot of uncertainty, so you'd have a fairly wide distribution, to very narrow distribution, which would tell you that you have not very much uncertainty at all. If we move on to life loss, here's a table that represents the life loss values. So for example, in your without project alternative, you could expect your annual life loss to be about 3.7. In 100 years, it would be 5.3. In 250 years, your annual life loss would be 8.9, or not your annual life loss, but your probable life loss over that 250 years would be 8.9. In 500 years, it'd be 22 people. But you can see as you build your alternatives, your life loss continues to go down depending on the alternative. And again, the 30-foot high levee gives you a significantly reduction in life loss until you get to some very large events. And when you get to the very large events, then all of a sudden those numbers go up. Why? Probably because more people have encroached interior to the levee, and now more people are actually put in harm's way. Kind of interesting that you put in a levee and your actual values of life loss can go up. So does a levee always reduce your risk? Not necessarily. So residual risk. Residual human health and safety risks will be displayed. They'll be displayed based on the narrative that you create. To aid in the display and to improve the understanding of the residual risk, inundation maps showing flood depths should the project be exceeded, shall be provided as well. So flood inundation maps are a great way to help people visualize their flood risk. Also, in a probability comparison report, which is what we see here, we see a comparison of flood risk to other types of risks someone may experience over time. The purpose of this table is to help people understand their flood risk in relation to other risks that they may have experienced, such as fire damage, wind damage, or earthquakes. I find it kind of interesting, though, that these numbers that I'm reporting here are based on an average between 2002 and 2010. I would like to see these numbers updated based on the fires that we've had here in California and actually throughout the western states. I suspect these numbers would go up significantly because of the many fires that we've experienced in the last 3 to 5 years. So in the narrative, to improve the understanding of the residual risk, as we talked about before, a narrative scenario for the events that exceed the project design shall be provided. So it's not you want to do a narrative, you have to do a narrative. And the narrative does a great job of helping you understand what your residual risks are. And again, those residual risks are the risks that you incur after the flood. So not after the flood, I'm sorry, the residual risk occurs when your project performance is actually exceeded. So let's give you an example of what that narrative might look like. Very long narrative. What I've tried to do is highlight in red the things that you need to hit. So these things that you need to have in there are human health, safety risks, the environment. These should be discussed. The extent to which the project can achieve an economical, resilient, and predictable system, including capacity exceedance, should also be provided. So again, life safety, terms like floodwater would likely remain in the new town for 2 weeks or more. You have a 1 in 2.5 chance in 50 years of the project being exceeded, which is giving people a perspective that's nearly the same as flipping a coin and getting heads. The emergency action plan needs to be developed and training exercises need to be performed. It talks about the environmental issues, the resiliency that measures could be considered. So what could you do to make the project more resilient? And resilient measures for a levee can be provided by adding superiority increments. So certain areas could be higher than other areas to provide additional protection or to assure that if the levee is going to get overtopped, it will get overtopped in the specific location. So we have now completed the third of 4 presentations in this series. In this presentation, We introduced the NED plan and the reporting requirements. Now would be a great time to capture any questions you have on this session, and we can discuss them later in one of our discussion sessions. Thank you.